Hi guys, today we're talking about rational expressions and we're going to be simplifying them. So the first thing we need to do is talk about, well, what is a rational expression? Remember that word rational that has ratio in the first part of it? That means we're talking about some kind of fraction, right? So a rational expression is nothing more than a fraction in which the numerator, so remember the numerator is the top of the fraction, and or the denominator, and the denominator is the bottom of the fraction, are polynomials. So remember polynomials, we just worked on that last unit, are numbers and variables multiplied together where the variables, where the exponents are always positive whole numbers. So that's what a polynomial is. Sometimes we'll have more than one term added or subtracted together, remember? So we can have many monomials added or subtracted together. Those are polynomials. So in order for it to be considered a rational expression, the denominator's degree has to be at least 1. So, for example, a rational expression might look like 3x squared plus 5, not sure why my pen is doing that, over 10x. Okay, so 3x squared plus 5, that's a polynomial because my exponent is a positive whole number. This one is a monomial that doesn't have a variable. They're combined through addition. So that is a polynomial. On the bottom, I have a polynomial, 10x. It says that the degree must be at least 1, which means I must have at least one x on the bottom. Remember, that would be x to the first degree if I don't see it. It doesn't have to be 1. It can be something bigger. So I might have something like 10x squared plus 2 over 3x squared minus 7. Okay, that's a rational expression. The top of the expression doesn't necessarily have to have a degree in order to be considered a rational expression. So something like 1 over 3x plus 2, that is a rational expression as well. So just the denominator has to have at least degree 1. And then it's a ratio or a fraction of 2 polynomials. Okay, so that's what a rational expression is. Now, before we begin, since we are going to be working with rational expressions, which are a type of fraction, we're going to review how to simplify just a regular fraction without any variables or anything like that in it. So once we add variables, it's a rational expression. But if I had something like 5 over 10, 5 over 10 is a fraction, and it's a fraction that can be reduced. So I can reduce this fraction because 10 is the same as 2 times 5. And I know that 5 over 5 reduces to a 1, so those will cancel out. And then the only thing that would be left on the top here, since the whole 5 went away, would be a 1. So 5/10 simplifies to 1/2. And so we're going to be doing the same thing going forward. We're going to be looking to simplify rational expressions. What that means is we want to find common factors in the numerator and the denominator that will cancel out. So let's try something else. Let's say I have 26 over 39. Okay, I want to reduce this fraction. I want to see if they have any common factors in them. Okay. It looks to me like since the bottom is not going to be divisible by 2, I might want to try dividing these by 3. So this would be 3 times 13. But the top is not divisible by 3, but I can see that it is 2 times 13. So I have 2 times 13 over 3 times 13. So the 13s do cancel, and this would just be equal to 2/3. So as you're simplifying fractions or simplifying rational expressions, either way it's the same thing. We're looking for common factors that will cancel out. So 6 over 18, 6 is 2 times 3, and 18 is 6 times 3. So the 3's will cancel, and I'm left with 2 over 6. But then this reduces further. The top is 2 times 1, the bottom is 2 times 3. The 2's will cancel, so it simplifies to 1/3. So you may have been able to tell by looking at 6 over 18 that it's simplified to 1/3. But I'm just trying to show those steps and why it simplifies to 1/3, because we're now going to apply that to rational expression. Okay, so let's give it a try. So here I have 8k squared over 24k to the third. Okay, so I can look at the number part of this. So like the 8 over 24, I'm going to look at that separately first, and then I'll look at the k's in a moment. So 8 is 2 times 4, right? And 24 is 2 times 12. So those 2's will cancel. And then I'm left with still the k squared over k to the third. Okay. But then it looks to me like we can also divide this again. 4 goes evenly into 12. I guess 8 goes evenly into 24. We could have done it that way. So I've got, on the top, I've got 4 times 1 times k squared. We don't really have to write the times 1, right? And then 3 times 4 is 12 times k cubed. So the 4's will cancel out. So I have k squared left on the top, and I have 3k cubed left on the bottom. Now I can use my rules of exponents, or I can go ahead and just, how many of these will cancel out, how many will be left. K squared will cancel with k squared down here, and it will leave 1k on the bottom. So this simplifies to 1 over 3k. Now, because this has a k on the bottom, and this original had a k on the bottom, I have to think about like what k values will work for this, right? There's going to be some what we call excluded values here, because anything that will make my denominator equal 0 is going to be excluded, because I cannot divide by 0. So if I plugged in a 0 for k here, I would get 1 divided by 0, and 1 divided by 0 is undefined. That's not an operation that we can do. It doesn't make any sense to divide one item into 0 groups. It just isn't, it doesn't make sense, and it's undefined. So because of that, my denominator cannot be 0. So that means, and we'll always start with the original denominator. Even if the k's all canceled out on the bottom, we would still have to think about excluded values. So we go back to the original problem, and we're going to set the denominator equal to 0 and solve for k, so that we can find the value of k that would make the denominator equal 0, if that makes sense. So we're going to divide both sides by 24. So I have k to the third power equals 0, which means k must be 0. Okay, and we can see that that's true. If k were 0 here, then this would be undefined. So the solution, or the simplified version of this, is 1 over 3k. But then you're going to also be asked to say what k cannot be. In this case, k does not equal 0. Okay, so on these, there's going to be 2 parts of your answer. One is the simplified version of the rational expression, and the second thing is what can k not be equal to? What would make my denominator equal 0 so that it would become undefined? And then we need to exclude that value. All right, so let's take a look at another example. We have 49p squared over 56p. So again, we are looking to find common factors that we can cancel out. So 49 is 7 times 7, right? So let's just write the top out all as factors. P squared is p times p. 56 would be 7 times 8, and then we have times p. So we know that a 7 is going to cancel, a p is going to cancel. On top, we're going to be left with 7p, and on the bottom, we're going to be left with 8. So that's as simplified as we can get this. But then again, we have that question, what can p not be? So on this one, notice p disappeared in the bottom, it got canceled out. But because our original problem had a p in the denominator, we are going to think about what p cannot be in the original. So in order to find what p cannot be, we always take the denominator and set it equal to 0. and then solve for p. So on this one, 56 times p equals 0, which means p must be 0, because anything times 0 is 0, right? If I wasn't sure, I could undo times 56 by dividing by 56. So p is equal to 0 divided by 56, which is just 0. So again, on this one, p cannot be 0. It can be anything except for 0, because 0 is going to make my denominator equal 0. Okay? Just a note here, it is okay to divide 0 by a number, it's just not okay to divide a number by 0. So 0 just can't be on the bottom of the fraction. All right, 45x divided by 36x squared. Let's just start breaking this down. 45 and 36, I'm thinking 9 might be their common factor. So 9 times 5 times x on the top. And then 9 times 4, right? Yeah, 9 times 4 times x on the bottom. I don't know why my pen keeps doing that, but it's annoying. Okay, 9 over 9 would cancel. X over x would cancel. On the top, I'm only left with 5. On the bottom, I have 4x. So it simplifies to 5 over 4x. And then what can x not be? Again, x can't be 0. Because if I set 36x squared equal to 0, I divide both sides by 36. X squared equals 0. And then in order to get rid of the square, I would take the square root. Those cancel each other out. And the square root of 0 is 0. So again, x cannot be 0. Okay, so we always need to, on these, we need to state that excluded value. It just means what can x not be, what's undefined, what values of x make this undefined. All right, so this one looks a little bit different. We have 8n plus 80 over n plus 10. On these ones, we have to be really careful because now everything is not multiplied together on the top or on the bottom. Now we have a plus between the top and a plus between the bottom. Whenever we have a variable with a plus or minus between it with another number, we have to think of this as just one number, okay? We don't know what n is right now, but like if n were a 5, I would just add it together, right? 5 plus 10 is 15. The bottom would just be one number, it's 15. So I cannot divide this thing up. I can't simplify like half of it. Like I can't say this n cancels with this one because instead of being multiplied down here, this isn't 10 times n, this is 10 plus n. Likewise, I can't just cancel an 8 or a 10 out of 80 and leave 8 and this 10 because it's only half of this plus or minus. Same thing with this one, okay? So anytime you have a variable in one side with a number on the other and there's a plus or minus between here, do not try to cancel half of a plus or minus out on these, okay? So what we're going to do instead is we're going to find the common factor in the numerator and we're going to pull it out. So basically we're factoring the top as much as we can. And I see that there is an 8 in common in 8n and in 80. So I'm going to pull that 8 in front of the parentheses, which is going to leave an n and then plus 10. So go ahead and double check. If I were to multiply the 8 back in, I would get 8n plus 80. So this is still the exact same as 8n plus 80. It just has the 8 pulled out in front. And then that's over n plus 10. Okay, now that this entire number matches this entire number, now we can cancel it out. So this whole thing just simplifies to 8. We still need to think about what n can't be, and to do that, we're going to look at the denominator. So set n plus 10 equal to 0 and solve for n. So I would subtract 10 from both sides. So n equals negative 10 would give me a 0 in the denominator, which means n can be anything except negative 10 because I don't want my denominator to equal 0, right? If I put a negative 10 in here where n is, I would get 0 on the bottom, and that would be undefined, okay? So let's try another one. 45 over 35n plus 45. So again, it's really tempting to just cross out those two 45s. We can't do that because this is not multiplied by the other things down here. It is added. So we need to think of this as one number. Okay. So instead what I'm going to do is I'm going to factor out the greatest common factor in the denominator. So I'm going to pull out a 5. So 35 divided by 5 is 7. So this would be 7n. And then 45 divided by 5 is 9. So I can pull just the greatest common factor out. The 7n plus 9 is a number that I can't break away half of it. I can't cancel out half of it. I just have to think of it all as one number. So the only way 7n plus 9 will cancel out is if there's another 7n plus 9 on the top. 45 is 9 times 5, right? And then we have the 5 times 7n plus 9. So those two will cancel, and I'm left with 9 over 7n plus 9. Okay. Oh, and then what can n not be? Right? It's going to ask us, what can n not be? Again, just take the denominator. Oh goodness, I don't know why it is doing that. 35n plus 45 and set it equal to 0 and solve for n. So in order to get rid of plus 45, I've got to subtract 45 from both sides. So that gives me 35n equals negative 45, and then divide both sides by 35. I'm moving down here. The 35s would cancel, right? N equals negative 45 over 35. And then I could reduce that fraction to negative 9/7. So n cannot be negative 9/7 because negative 9/7 would give me a denominator of 0. Okay. So always just take the entire denominator and set it equal to 0 and solve for n in order to find that excluded value. And sometimes there can be more than one excluded value. We'll see some of those examples in a moment. So 30 over 15x minus 5. Again, don't try to cancel out half of it, right? There's a minus here. We can only cancel out something like that if everything is multiplied. So what I'm going to do instead is I'm going to pull out that common factor, which is 15, which will leave x minus 1. So 30 is 2 times 15, right? So this 15 and this 15 will cancel. So I'm just left with 2 over x minus 1. So in order to find the excluded value, I am going to go ahead and set the denominator equal to 0. And solve. So x cannot be 1. Because if x is 1, that will make the denominator equal 0. Now on this one, I could have just looked here. The problem the reason I'm using this one on all these examples instead of this one is just in case something canceled out. If something canceled out, we need to, or like if x canceled out specifically, if any part of the x cancels out, then we need to use this one instead of this one. But if none of the x's disappeared, then it's okay to use that one to find your excluded value. All right, so on this one, we have n squared plus 2n minus 35 over n minus 5. On this one, I want to factor this. Remember, this is all considered one number. Basically the same thing for this. So in order to cancel anything out, we're going to have to get this in factored form and see if one of my factors happens to be n minus 5. Right, so we'll use x factoring here. I need two numbers that multiply to a, which is 1, times c, which is negative 35. So what are two numbers that multiply to negative 35 and add to b, which is 2? So that would be a negative 5 times 7 would give me negative 35 if I multiplied them, and positive 2 if I add them. So the top, I'm going to have n minus 5 and n plus 7. And on the bottom, I've got that n minus 5. So now the n minus 5 is going to cancel with the n minus 5, and I'm left with n plus 7. So this is the simplified expression. But now don't forget, I need to say what n cannot be. So again, take the denominator from the original problem and set it equal to 0 and solve for n. So I'll add 5 for both sides. So n equals 5. That's what's going to make my denominator equal 0. So I know n cannot be 5. Okay, so remember your answer needs two parts here. All right, so on this one, it looks like I need to factor both the numerator and the denominator in order to see common factors. On the bottom here, I'm going to rearrange this so that my equation, my polynomial is in standard form. So irritating. Okay, so negative 9n squared minus n plus 72 would be on the bottom. Let's just x factor here for the numerator and the denominator. So on the top, we have 1 times negative 24. That's the number we need to multiply to. And negative 5 is the number we need to add to. So let's see, I'm thinking 8 and 3. So 8 and 3 with the 8 negative. So n minus 8 and n plus 3. On the bottom, a is negative 1 and c is 72. So a times c would be negative 72. B is negative 1. So what multiplies to negative 72 and adds to negative? All right, so two numbers that multiply negative 72 and add to negative 1 is negative 9 and 8. Now remember that we always need to divide our numbers by a. In this case, a, as I rearrange this here, a is equal to negative 1. So I would divide each of my factors by negative 1. So this is actually going to give me n plus 9 and n minus 8. So the n minus 8 will cancel with the n minus 8, which means the simplified expression is n plus 3 over n plus 9. All right, so now we need to think about our denominator, our excluded values. What can n not be? So we would want to start with the denominator before anything got canceled out, but this is the factored form of that, and this is the one that's easy to tell what n should not be. So if n plus 9 times n minus 8 cannot be 0, or if we set them equal to 0, then we would see that n equals negative 9, right? If n plus 9 equals 0, I would subtract 9 from both sides to get n equals negative 9. And likewise, on this side, n would equal 8. So n cannot be negative 9, and it cannot be 8. Okay. So let's try one more, last one. So on this one, on the top, I have 5x minus 50. So I see that they have a common factor of 5. So I'm going to pull that out. So anytime you have a rational expression that you're trying to simplify, you would want to start by making sure everything is as factored as possible, right? So the bottom, we're going to use x factoring. What two numbers multiply to? 80 and add to negative 18. So that would be 8 and 10. Since they multiply to a positive but add to a negative 18, we want both of them negative. So this would be x minus 8 and x minus 10. So that's going to cancel, and my reduced expression is just 5 over x minus 8. In order to get my excluded values, I would need to look at both of these in the denominator. We want it factored, but before it gets canceled out. So we know x cannot be 8 or 10. Okay. So go ahead and try those problems. If you have any questions, please let me know, and I'd be happy to help you. Okay. Have a great day.